Today we'll be going over section 6.2, addition and subtraction of fractions. First, we will review the addition of fractions with common denominators. As you can see here by my example, a over b plus c over b always equals a plus c over b. So when we have common denominators, such as number 1, 2 over 3 plus 1 over 3, that's 2/3 plus 1/3. So all you'll do is simply add the top. 2 plus 1 equals 3. And you keep the denominator since they're the same, so it'd be 3 over 3. And just so you know, 3 over 3 is also equal to one whole number. Now if we go down to number 2, we have 1/5 plus 2/5. 1 plus 2 equals 3. We carry the common denominator. It'd be 3 over 5. Now let's review some graphing representations of addition with common denominators. Here we see 2 over 6. Plus 3 over 6. We have it in the pie, 2 out of 6, 3 out of 6. 2 plus 3 equals 5, and we carry the common denominator equaling 5 over 6. And we have shaded 5 out of 6 of the pie parts. We also have a number line. So if we go from 0 and jump to 3/17, if we add an additional 3/17, that would give us 6 over 17. Now let's look at the subtraction of fractions with common denominators. As you can see by my example, a over b minus c over b equals a minus c over b. Now for number 1, we have 4, 6 minus 2, 6. So we'll do 4 minus 2 equals 2, and we'll carry the common denominator equaling 2 over 6. The same for number 2. 3/4 minus 1/4. 3 minus 1 equals 2. 2 over 4. And again, this is also equal to 1/2. Now let's look at some graphing representations for the subtraction of fractions with common denominators. Over here you can see that we have 6 over 8 minus 2/8. We're going to take 2 of the shaded areas away, which is going to leave us with a remainder of 4. So 4 over 8, which is also equal to 1/2. Here you can see we have 4/5. We're going to subtract 3/5, which is going to leave us 4 minus 3 equals 1. Carry that common denominator. It'll be 1/5. Now let's go over the addition of fractions with unlike denominators. Here you can see that I have 1/3 plus 1/4. Now, when we have fractions with unlike denominators, we will have to come up with a new denominator. So what we're going to do is we're going to cross multiply, and we're also going to go across. So we need to find a like denominator that both of these numbers can go into. And if you take 3 times 4, that equals 12. So let's use 12 as our denominator. So 1 times 4 is going to give us our numerator for 1 over 3. So 1 over 3 is going to turn into 4 times 1 equals 4. 3 times 4 equals 12. So our 1/3 will turn into 4/12. Now if we take our 1/4, again, 3 times 4, that's going to be our denominator. To find our numerator, we're going to go 3 times 1. That's going to give us 3/12. And when we add these two together, we get 4/12 plus 3/12. It's going to give us a total of 7/12. Now let's look at some representations for the fractions that we just looked at. So we'll go back to our original fraction of 1/3 plus 1/4. Here we have an example. We have a diagram showing us 1/3 and 1/4. 1/3 is going to turn into our 4/12. 3 times 4 equals 12, our denominator. 1 times 4 equals our 4. The same with 3 over 12. We add these together, we get 7 out of 12. Now let's look at the subtraction of fractions with unlike denominators. For this example, I have created 4/5 minus 1/3. Now with this, we're going to do similar to how we did the addition, where we're going to cross multiply to get our numerators, and we're going to multiply across the bottom to get our denominators. So first, we need to multiply The denominator is 5 times 3, which is going to give us 15 as our denominator. Okay, so then for our numerators, again, just like we did previously, 4 times 3, that's going to give us 12 for our 4 over 5ths, and then 1/3, that's going to give us 1 times 5, 5 over 15. Now when we subtract 12 minus 5, that's going to give us, I'm sorry, I'm having a brain part right now. 12 minus 5 is 7, 7 over 15 will be our answer. Let's do a few more examples of these. 2/6 minus 1/2. So we're going to find our denominator. 6 times 2 equals 12. So that'll be our denominator. Then we need to find our numerators. 2 times 2 equals 4. 1 times 6 equals 6. We've got 4 minus 6/12, which is going to give us 4 minus 6 is a -2. Carry the 12, -2/12. This it can actually be reduced by 2. So if we reduce it by 2, it's going to give us -1/6. Sorry for that brief interruption. So now we're going to go to number 2. We have 3/8 minus 1/3. 8 times 3 is going to give us 24, which is going to be our denominator. And then we're going to do 3 times 3, which is 9. And 1 times 8, which is 8. So we have 9 minus 8 over 24, which is going to give us 1 over 24. Now, let's review mixed numbers and fractions. Okay, so for the following example, I've provided 1 and 2/3. Now, this number 1 actually represents a whole number. So that means that it was 3 out of 3 equals 1. So 3/3 would equal 1. That's one whole number. So this is actually representing 1 plus 2/3 of one number. So that'll be one whole number and 1 2/3 of a number. Now, when we take a mixed number, we could actually make it come into standard form. Now, the way we do it in standard form is we take the denominator, which would be 3, we multiply it by the whole number that is given, and then we add the numerator over the original denominator. So when we multiply the denominator 3 times the whole number 1, we get 3, plus the numerator 2 would equal 5. And if we put that over that original denominator 3, we get the answer 5 over 3, which is the standard form of our mixed number 1 and 2/3. Here I have a different representation of a mixed number being turned into standard forms. Here again I have the 1 and 2/3 equals 5/3. Here you can see one whole number and then 2/3. So this represents 3 whole thirds and this represents 2/3, and when we put it across you can see it's equal to the same thing. This is just 3 out of 3, which would be one whole number, and then 2/3, which equals the same thing. 1 over 2/3 equals 5/3. Okay, now we can start reviewing proper and improper fractions. When a fraction is proper, this is when a number or the absolute value of letter A is between 0 and B. For example, 2/3, 2 would be either less than or equal to 0, which would be greater than 3 or less than 3. So this would be a proper fraction. 3 over 5ths would be a proper fraction. 4 over 8ths. For example, if this was 8 over 4, that would be an improper fraction because that number would be larger than the denominator, which would be B. The same for 3/5. If we swapped it to 5/3, that would also not be a proper fraction. Now, I kind of just explained that already, but we'll go ahead and jump into it when a fraction is called improper. This is basically when A is larger than B. Anytime A is larger than B in a fraction, this is going to be called an improper fraction. For example, 236 over 12, that's going to be an improper fraction. 113 over 10, 312 over 9. All of these are going to be improper fractions. 64 over 10, etc. It doesn't have to be a double number. It doesn't have to be a triple number. It could be any number that is larger than the denominator. and that is an improper fraction. Thank you very much. That will sum up our brief summary for section 6.2 on the addition and subtraction of fractions. Thank you.